Good morning. It is day 23. Um it's been 23 days since I think I've done two applications to internships in these 23 days. Just not good. Need to do better. Um See, I have this like mental block right now where it's like I already have submitted over 100 applications like this fall, and I got literally not even a phone interview. And so I'm like, okay, obviously, like my resume has to be fucking not that good. I mean, we can see. Ooh, do I have my? I don't think I have my resume on my portfolio website. I need to change that. I need to change actually a lot of this. There's so much that needs to change. Like this kind of just looks ugly. Like I kind of want to change this a bit. I want to change this about, and I should have all my contact stuff over here with a picture. Um, anyways, I guess I can just open up through here. Desktop, internship apps, resume. This is my resume now. So I have uh my research I did this summer, my research I did the summer before, and then I have the product I made out of this research, and then I have a full stack application I made, which you'd think that'd warrant like at least a full stack. I guess it is weird, right? Because it's like it's really hard to get into the machine learning space, right? And I'm not. It's just lined up to where like oh my god, where my interest, like when I go into these research things, they'll lay out like, okay, what's your interest? The most interesting thing always gravitates towards me as machine learning. So I'll say machine learning, so I get placed in these machine learning teams for research. Um, and so that's all my experience is just in machine learning. But it's like it's definitely significantly hard to get a machine learning internship over like I don't know, full stack or something like that. But so it'd be nice to my have resumes where the projects, like I think the biggest downfall of my resume right now is they see that overlap. And so if I'm applying to stuff that isn't a machine learning based position, which a lot of them aren't what I'm applying to, they see a machine learning based application, um, and the research in machine learning and the other research in machine learning. And so it's just a lot of machine learning. So it'd be really nice to get this application done, the code visualizer that we've been working on. And then I want to do like the packet sniffer, um, uh, or not but also maybe something else. I thought it'd be cool to explore some more computer architectural stuff because I'm taking computer architecture next semester and just kind of get um, acquainted with that. But I want to do something in C. I want to program something in C, a project, and so maybe that's the packet sniffer. It'd be cool to do a C to assembly compiler. That'd be pretty cool. But we'll see. Um, right now, I have no plans except working on the code visualizer application and LeetCode. So I have to leave at 1:30. So I think what I might do is do the two LeetCodes now and then start working on the app. And then I think I'll pause the recording and then still resume when I come back up until like I assume there's what football games are there today? NFL schedule. Um Lions Bears boring game, boring game, boring game. Oh, Bengals Browns actually wouldn't be bad. I want so badly the Bengals to sneak into playoffs. That'd be so sick. Bills Patriots. I mean, Patriots will probably. I mean, Patriots are gonna get stomped, but it could be an okay game. Bucks Cowboys could be okay. Just not a lot. I kind of only care about this Bengals game. Yeah. Okay. So get started on some LeetCode. Also, let me turn this down a smidge. Okay. I also feel like trash today again. My sleep has been so bad these last couple days. Oh, also I got the discrete math exam back, and I got a like a C plus on it. So I mean, I finished the class with like a B minus or a C plus. So that's good because I really thought I would have done much worse on that exam and gotten a C minus, and that would have been terrible because I that would have like made it so I wouldn't get the prerequisites to other classes. So really good, really good. Yeah. Given the root of a binary tree, return true if it is valid. If it is a valid binary tree, otherwise false. The left subtree of every node contains only nodes with the node's key. So everything, given the root, everything over here has to be smaller and everything over here has to be greater. Wait, a valid binary search tree satisfies the following constraints. Now let's pull up our little draw tool here. So a valid binary tree contains the following: the left subtree of every node. So given a node, its left subtree. So this would be a left subtree. And so would you call this the left subtree of this node? You would, right? So the left subtree of every node contains only nodes that are less. So if the value of this is 4, and then this is 3, this is 2, and this is 3, this is valid, right? Actually, no, this is valid, right? This is a valid tree. Because it's just saying for every node, but it's just weird because it's saying the left subtree. Is this not the left subtree? Because it says for every node. So for here, this would be the left subtree. This would be the right subtree. But then this, so would it technically, would this have to be like 5, 3, 2, 4? Like, is this valid? Is everything is less than this, and this is the left subtree technically? I think that's what it's saying. Right, so this would be valid. I think so. So it's given a node, everything to its left needs to be smaller than it. And everything to its right needs to be greater than it. So when I get to this 3, right, this 4, this needs to be 5. But then I think if I made this a 3, right, this would now be invalid because everything over here has to be greater, and this isn't greater. Let me actually see if ChatGPT can. Wait. I thought it was the. I'm pretty sure this rules out because of this 3 right here, or. But. Node 5. Wait, wait. You're saying node 4 is less than. What? Strictly less than the node. Yes. Okay, yes, now you're saying it right. I swear it's been saying it wrong the whole time. Yes, this is broken because of this. Because technically, right, we're now saying that everything to the right of this needs to be greater. everything, and this is not greater, this is equal to, so it breaks it. Okay, thank you. I don't know why that was so hard. Okay. So, um, so how can we, what is an algorithm that, so obviously over here, this would have to be at least like 6. Oh, but if this is 6, it can't have this node, right? If this is 6, it has to stop. So if this is 7, right, then this can be 6, and this could be 8. So this is a valid tree, right? Now, how do we figure that out? Well, given any node, its left value has to be less than it, and its right value has to be greater than it, right? So for this one, checks out. Now for this one, this has to be less than, this has to be greater than, checks out. For this one has to be less than, this one has to be greater than, okay? Now, what we're missing here is that for this, right, now everything over here has to be greater than this, right? The entire subtree. So the entire subtree, every single value has to be greater. Over here, every single value has to be less than. Oh, I guess this also violates it, right? Right? This also violates that. Did it say this? So we have to keep track of, so like given this node, we know that when we do a recursive loop on this left side, we have to know, like, okay, everything has to be less than this. So this could be a max thing again, right? Or no. It's just everything has to be less than this, right? Actually, once you go from, okay, everything down here has to be, the next node has to be less than this on the left side, right? And then whatever value this is, we don't even have to care about the 5 anymore. We can just say, okay, given a 3, everything over here has to be less than, everything over here has to be greater than, right? And then we go down to this 2, everything has to be less than, everything has to be greater than. We go down to this 4, right? And we're like, okay, everything over here, right, has to be greater than, has to be greater than 3, but less than 4. Right? So where does, oh yeah, so over here, this also has that constraint of like, if this had another node, it can't have another node, right? Or it'll be invalid at any point. Okay. I need to use the bathroom real quick. But we're getting somewhere with this. Okay, I'm back. So I was thinking about it. By the way, I realize it kind of looks a little bad that like I go to the bathroom like a lot during these LeetCode stuff. I mean, even during when I'm working on projects, I'm never like looking up stuff. That would literally just hurt me. Like that's not the point of what I'm doing. So, um, but it is kind of funny. I don't know why I use the bathroom so much, um, but I do take the time to think. um, and so I was thinking, and um, I I want to try to do this as efficiently as possible, right? So it's like the whole issue I'm running into is it's like, okay, I check to make sure this is less than right at the root. Sure. But then when I'm here, I need to check this is less than and this is greater than, right? But now the whole problem becomes when I'm checking these less thans, I can update the value to this root node. I can say, okay, everything has to be less than this. That's fine. Everything has to be less than this. That's fine. It's when we get to this greater than, because this right here, technically, it's like, okay, we can do everything greater than this, but not equal to this. So technically, I can't update this. I guess is that a stipulate? Would that be easy to implement? Coming down from 3, this is now my new root, but I still keep this value, and I say, okay, if this is greater than this, but less than this, then it's valid. Right? Oh yeah. And then so I'm pretty sure I can keep, at all times, I need to keep 2 values back. Because I need to say this, right? This needs to be less than this. It needs to be less than this, but greater than this. This has to be less than this. And then over here, this has to be greater than this, but less than this. Okay, yeah. I think that's actually flawless logic. So, so what do we want to do here? We're not forming any arrays or anything. We're literally doing a def trajectory that's going to be passing in the node value, the previous value, in the previous previous value, right? I mean, is that not what's happening? Right? I need to keep this value and this value, if those values so exist. In last prev. Let's say this, okay? And so first I want to do my whole if root is none, return true, right? If node is none, if the node was ever none, but we never returned false, we just want to return true, I think. Right? And so we want our current node.value. We want our right is equal to, actually I should do left. Left equals node.left, and right equals node.right. So I'd assume this is going to be like an if cur is not none and check tree passing through left cur see, but it's like, how do I pass through the last one? Do I have to start at the beginning of like, you understand what I'm saying, right? Is it's like when I'm starting here, I can take the current, I can take the next, but there's no previous. So I mean, yes, technically this would be none. Actually, so I'm gonna pass this through as none the first time, right? And the next time it comes through, so like when I first do this, left is gonna be 3, current is going to be 5, and left priv will be none. So on my next call, left is gonna be 2, current will be 3, last priv will be 5. So what? Last priv. Last priv equals current. In this scenario, it's going to be passing it through. No, because then there'll always be. When I pass this through, right, I'm calling it again with left, current. So in this case, this is 5 and this is 3, right? This is none when I first call this through. This next time, I want to update it with what current was. So once we rewrite the new current, right? So new current is going to be this value, right? But before we do that, I want last prev to equal the node, right? So like on this first iteration, it'll be none, but then instantly it's going to be equal to 5. So now if I do my my validation checks, right, and I say this needs to be less than this, and this. Oh, that's only if I'm checking right. Well, no, it needs to be greater than previous, but less than last previous. So it has to be if if step is not 1. I was gonna say I like just pass through like a step, and then I just say like step plus 1, whatever, right? And this is if left is not known. Right. Obviously, I need a call check tree with root. I never set previous to. Oh, okay. Previous is just What, 0, 0, 0? Or I guess this would be none. None, 0. I thought this was invalid in fucking Python. Wait, why is it doing this? I always do that. Obviously, I haven't put in the logic yet, so, but. So, where would I put in the logic? Would it be before I call the recursive call? I'll be honest, I also don't really get recursion in the fact of true or false returns. Like, if this just goes through. So, I mean, it should be after all these updates, right? I should be like, okay. So, on this first iteration, right? I need to say, okay, if left is not if left is greater than the current value, return false. If right is less than the current value, oh, this should be actually greater than or equal to or less than or equal to, return false. I also want to check if right I think I want to do these checks in here, right? Because like right now I want to say, okay, so like in this scenario over here, I want this to be greater than this. Oh, if it's actually greater than this, then that's fine. It's this that needs to be, so this. This has to be greater than this, but less than that. So it's, so over here, it's if right is ever, if it's ever greater than or equal to last previous, return false. And if left is ever greater than, or sorry, less than or equal to last previous, return false. But this is the thing, is like over here, if this, you're saying if this is less than or equal to this, which it's always going to be. Wait. Yeah. So I only want to check this once we've gone down the right side, right? So I might need to do another helper function that calls this, or, or, mm, you know what's fucking stupid? I could say check right tree, or check left tree, sorry. Actually, I mean, it doesn't matter. Just redo this entire thing. No, that's stupid. It'd be better if we did a it'd be step and side. So I do a left, and then I do the same thing, but on the right. So I wouldn't, if right is not none and step is not zero, right? Or sorry. My brain. It should be if right is not none, right? But I don't want to go down the right side if it is a left call. So I don't want to recursively call. So like in this recursion, it would go like this. But if I don't go off here and I go down, then it'll just go down that side. So if I call it on left, then I want to say if right is none, and if it's called with left, if okay no, if we're called with right, in what situation do we want to do this? Or I guess what situation do we not want to do this? In the situation we wouldn't want to do this is when step is 0 and it's left. So if step is 0 and it's right, This is so inefficient. Oh my god, bro. Right. So if we're on step 0 and it's right, then do this. What I can't why can't I think of what the condition would be on just don't do it on the first iteration of left? If we pass through that it's left and it's on step 0, just don't do this. Oh my god, just if it's step 0 and this is left, pass. Else, do it. Same thing up here. If left is not none, and this will just pass through side every time as well. If step equals 0 and the side is equal to right, pass. Else, just do all that. If side equals right, then we want to check this. And in both cases, we want the left. This is horrible. This is disgusting code. This is absolutely disgusting code. Oh, num type object. Yeah. Okay. You know what? Fuck all of this. This is so bad. Well, actually, no. I'll keep this and that. Let's just start clean. A clean mind. This is actually so bad. I've spent too much time on this, actually. At this point, it's just becoming inefficient. Ugh.
Hey everyone, welcome back, and let's write some more LeetCode today. Solving validate binary search. A very good question for practicing binary search tree questions. We're just given a root of a binary search tree, and we just want to determine, is it a valid binary search tree or not? And from learning data structures and algorithms, you might know that a valid binary search tree is such that we have a node like 2, and every single node in the left subtree, 1, and if it possibly had other children, is going to be less than 2, right? So 1 is going to be less than 2. And problem, but let me show you what you might try. You might just try a simple solution like, hey, 5. We have 5 as the root. Let's check its child. Okay, 3 is less than 5. That's good. Okay, let's check the right child. Okay, 7 is greater than 5. That's good for us. 4 is less than 7, and it has a right binary search tree. The answer is no, because it's really easy to miss. We have a 5 as the root, we have a right subtree over here, and we have a 4 in the right subtree. But we know 5 is not less than 4. That's subtree. Make sure that it's less than every value in the right subtree. And so we would need n comparisons to do that, right? O of n. And then we'd have to repeat that process for every subtree. So 7, we got to repeat that, compare it to every potential descendant of itself, which is going to be O of n. And the time complexity,
I'm pretty sure my approach is fine. I'm just
overall is going to be O n squared. So can we do better than O of n squared? So one thing to notice is the root value can be any value, right? There's no restrictions on what the value can be because it doesn't have any parents. So we can say that it can be any value between negative infinity and positive infinity. And as long as that's the case, 5 is okay. We don't have to make any other comparisons. 5 is between negative infinity and positive infinity. Okay, and then when we go down to the left subtree, we know 5 is good. We don't even have to check it anymore. But when we go down to the left subtree, what do we have to check? All we have to check is that 3 is less than 5. So in other words, we just want to make sure.
Okay, Jesus.
5 could have been anything. So there's no upper boundary yet. So we just need to check a right boundary. And 7 is less than infinity. So that's good. 8 is a binary search tree. And left child of 7 is then the 7 is or must always be search tree. False. And of this helper inside of our original,
quite literally my approach. Okay.
Function, we'll call it valid. We know search tree is still a binary search right boundary and a right function that we just defined.
Oh wow, he doesn't write this in his weird. Like I don't understand what this is. Left check equals static method lambda. Also, isn't lambda like an inside function? So lambda val is like a function with a value, and then the limit is that lambda function. Interesting.
Of our original function. We'll call it valid. We know we need to pass in the node since we are going to do this recursively, and we're going to have two boundaries, left and right boundaries. Like any binary search recursive function, if we reach a null
Oh, that is a really actually good approach for what to pass through. Because like I knew I wanted to be less than last previous, which was what my variable said. Like if I'm on the left side, but I want to be. I wonder how he deals with that,
node,
like being
we
different
can
on both
just
sides.
return. What are we going to return? We're going to return true because technically an empty binary search tree is still a binary search tree. And then we want to check, we want to make sure that node value is less than the right boundary and node value is greater than
So it's less than. Okay.
the left boundary. But we know if this is not true,
Oh yeah. Okay, that is pretty smart. Instead of doing, so that's how he deals with the left and right, is you just do boundaries. So I can do this as a right and a left boundary. Apparently, I don't need this. I can just um, leave it here, which I guess that does make sense. And what he does this as how do you define that again? Float. Okay. Yeah. Float. Um. So so for any given node, like this one, it has to be greater than 5, but it has to be just less than infinity, right? Oh. Oh my god, that 7 looked exactly. This 7 has to be greater than 5, but less than just infinity, right? But something like this has to be greater than 7, and I guess just less than infinity. This doesn't matter. But over here, this has to be 6, needs to be uh, greater than 5 and less than 7, right? So how are we figuring these out? It is I wonder how he deals with this. No dot left. What? What? Wait. You're passing this through just as left. Left is never updated. The left and right values are never updated. I mean, am I crazy? You're checking the bounds. Yes, sure. Oh, no, they are. Oh, whoa, whoa. Left is the same. Oh my God, if we're going left, the left bounds is always going to be negative infinity. If we're going right, the upper bounds is always going to be infinity. So we only have to change either the right bounds or the left bounds given this. So we're updating, let's say when we're traversing on the left side, we're updating our right bounds with the last value. Well, let's do right. Right is changing with the last node value. But wouldn't that make this, like if I'm checking 6, wouldn't this make it 7? How do I get 5 here? So like on that on so if we call this through on node dot left, the node dot value is the previous value, like here, right? So on this right side one, right, our left bounds is 7, and our upper bounds is just right, just infinity. Am I losing my fucking mind right now? Does this not just seem fucking weird? If I'm going, oh my God, I'm an idiot. I'm an idiot. That would be if I'm checking um I'm using for some reason the I'm using this to look at this when I'm supposed to be looking at this. Which I do this on a call, right? Okay. Brr. First call, right? First call of this. And we have 5 as the node, and this is less than infinity, but this is greater than negative infinity, right? That is on the first call. This is true. This is true. So we're going to go to this statement where we're going on both sides. I'm only going to track the right side for now, right? So we get to this right side. We do this call, right? And so our node is 7, right? Our left bound is the previous value. Wait, wait, wait. Okay, maybe I just have this switched around, whatever. But it's passing through 5 and infinity, right? As the bounds. Oh, I am doing this backwards because if you look at this. So it's saying 5 7, infinity, right? Infinity is greater than 7, blah, blah, blah. Checks out, valid. Then we go here, right? We go to we go to 6. And we pass through node dot left, right? So node dot left is this. What is our left bounds? Our left bounds is whatever left was. So it's negative infinity because we've never updated this yet. It's negative infinity. But our right bounds remains 5 because we're just taking. Actually, no. It's the node dot value. Wait, so then shouldn't this be? Oh my God. Oh my God. Yes, yes, yes. It is 5. This is 5. This isn't negative infinity. We have updated this value. We updated it right here when we called that. Okay. Brr. Oh my God. Okay. So I can just do this off the top of my head. It's going to be if not um the left bounds less than the node dot value less than the right bounds, right? If it's not this, then obviously this is just false. Otherwise, um, what? This is a return on. I just want to make sure it's a return. Yeah, return on check tree given um given when we're going on the left, we are doing node dot left. Our right bounds. Are we updating our right bounds when we're going down the left side? Is this it? I don't think so. I think this is just right. And this is no dot val, right? Let me think about this. If I'm going down the left side, right, on this one, I want it to be no dot left. I want my right boundary to not change. No. Yes. Oh, I forgot about fucking Python syntax. Wait. Okay, that's what I thought. And you just do that. Oh. I'm stupid. Return. Jesus. Huh? why you don't like if node. I don't think this changes anything. Why are you returning false? Oh my god. I'm a fucking idiot. Jesus. Okay. That took way longer than it should have. But this was I mean I'm glad that I like stopped trying my approach and just went and looked at what they had. Because I kind of have a rule of thumb that if it's gonna take me over like it should be over half an hour to do something, just stop. Because obviously I don't understand it well enough and I need to actually go look and understand it. So like this approach was really nice of like a bounds checking problem of where like my parameters can be a bounds check. And actually something really unique that I learned here is that um when I do a call, right, with a left and right, when I do this call, right, to go down to the left, and I update my left value, if I need to go when I go right now, I have a left bounds that's updated, which is, I mean, duh, but like, you know, it's cool, a cool concept. So, um, so yeah, wish it went a little smoother, but nice nonetheless. Kth smallest integer in binary search tree. Okay. Given the root of a binary search tree and an integer k, return the integer kth smallest value, one indexed, in the tree. The Okay. Okay. I need to go do something real quick, and then we'll return back to this. One second. Okay, I'm back. Sorry about that. So I was thinking about this one. While I was doing what I needed to do, and I feel like okay, so obviously I can actually do this really quick. Obviously, the easiest one would just be making a uh an element array, right? We're making this array, making a function def make array, which just takes in the node, and then we say if not node, return um uh and then and then you just literally call if okay, cur equals node dot value, left equals node dot left, right equals node dot right. If left is not none, then make array with left And also the whole thing is I want to do element array dot append the current value. If right is not none, make array right. Don't care about any of these. Call make array with root. Then afterwards I do sorted element array, and then for index in range of the length of the element array. Well, actually, in range of k. Sorry, k is one index, so we're going to want to do a +1 on this. So k plus 1. And I just want to if index equals k plus 1, return element array at k plus 1. Or just at index. Output was none. Pass through the node, current equals this, append the current value. If left is not none, repeat that. If right's not none, repeat that. What does this even mean? Print sorted array. 1, 2, 3. It wants to return 1. K is 1. So return. Oh, I want to return 0 here. If K is 1. If it equals K, then we want to return the sorted array at index -1. I don't get it. How could it ever be 0? Oh my god, I'm going to crash out. Print index and K. What? So I'm never reaching that. Okay. Oh my God. Okay. So obviously that is just a very, very, very brute force solution, right? Taking this entire thing, throwing it all into an array, traversing the array up until k, and taking that element, right? Um, which I would assume if I did that in an interview, they would say, okay, at least I know you can like use data structures, but that's really inefficient, right? Is there a more optimized way you can do that? And yes, there is, in which what I was thinking, right, is notice how in the description it says, oh, remember, this is what a binary a tree is. And so what I was thinking is like, okay, if we're looking for the kth smallest element and this right here, right? This is our starting node. So if this is 2 and we know this can only be lower than 2. We know that this can only be higher than 2. So this can only be uh, greater than 2. This can only be less than 2, right? This is what that means. So if we know if the kth is like 2, right? Well, I would assume what we can do is we can do, okay, 2 minus 2 is 0. So we don't move anywhere. We return the root. Let's say they wanted the first one, right? 2 minus 1 is 1. So we go 1 down this side. Now, if we have 2 minus, let's say 3, right? We might want to go to the third one. This is negative 1. But we can say if this is ever negative, that we go down this side by that much on like the positive scale. Now, I don't know how much actually this is like valid for, um, because I'd assume it's like a difference like that. I'd assume. Oh wow, he literally did what I did. Append, bam bam, call it on that, sort it, return k minus one. Okay. Oh, he does it for all of these are all. Never mind. I thought my approach was obviously I can clean this up. I'll clean it up to the point where it's just uh uh how did you sort it again? That was actually really cool. It was just array dot sort and then return element array at k minus one. It's one indexed, right? Yeah. Okay. I'll submit that version. That's just a lot cleaner. Um, and obviously I don't need this. I can just make it whatever. Anyways. Um, okay. Although I should, although I know there's something. I mean, what is this time complexity? It's probably still a good time complexity. See, it's n log n, where you could definitely make this like, then. Whoa. He swapped these around and the time complexity went down because I mean, he didn't use sort. Sort is obviously the thing that like fucks up this time complexity, but whoa. I'm guessing it's because it'll do like the left stuff and then the right, so it's like sorting itself. I'm guessing. I don't know. Okay. Oh, I never even typed out plan for deep work number 23. Wait. Oh yeah, it is 23. 2 leak codes. Work on visualizer. I also kind of wanted to look at I'm really scared to watch this video and he's gonna say the N word. Not gonna lie.
Sitting in my oh fuck.
No, okay, nope, nope, nope. I know that phone call clip. I I know that phone call clip. This is also something I wanted to do. I wanted
LLVM, a toolkit used to build and optimize compilers. Building a programming language from scratch is hard. You have humans who want to write code in a nice simple syntax, then machines that need to run it on all sorts of architectures. LLVM standardizes the extremely complex process of turning source code into machine code. It was created in 2003 by grad student Chris Latner at the University of Illinois, and today it's the magic behind Clang for C and C++, as well as languages like Rust, Swift, Julia, and many others. Most importantly, it represents high-level source code in a language-agnostic code called intermediate representation, or IR. This means vastly different languages like CUDA and Ruby produce the same IR, allowing them to share tools for analysis and optimization before they're converted to machine code for a specific chip architecture. A compiler can be broken down into 3 parts. The front end parses the source code text and converts it into IR. The middle end analyzes and optimizes this generated code. And finally, the back end converts the IR into native machine code. To build your own programming language from scratch right now, install LLVM, then create a C++ file. Now envision the programming language syntax of your dreams. To make that high-level code work, you'll first need to write a lexer to scan the raw source code and break it into a collection of tokens, like literals, identifiers, keywords, operators, and so on. Next, we'll need to define an abstract syntax tree to represent the actual structure of the code and how different tokens relate to each other, which is accomplished by giving each node its own class. Third, we need a parser to loop over each token and build out the abstract syntax tree. If you made it this far, congratulations, because the hard part is over. Now we can import a bunch of LLVM primitives to generate the intermediate representation. Each type in the abstract syntax tree is given a method called CodeGen, which always returns an LLVM value object used to represent a single assignment register, which is a variable for the compiler that can only be assigned once. What's interesting about these IR primitives is that unlike assembly, they're independent of any particular machine architecture, and that dramatically simplifies things for language developers who no longer need to match the output to a processor's instruction set. Now that the front end can generate IR, the op tool is used to analyze and optimize the generated code. It makes multiple passes over the IR and does things like dead code elimination and scalar replacement of aggregates. And finally, that brings us to the back end, where we write a module that takes IR as an input that emits object code that can run on any architecture. Congratulations, you just built your own custom.
It's sick. This was something I wanted to do because I'm taking computer architecture next semester. I wanted to do something relating to low-level systems and doing something in C. And so, I mean, like, I don't know if writing compiler is the best thing to do, but maybe. I think what I'm gonna do, because I have to go in like 20 minutes. I don't really want to start working on code visualizing app and then just have to go 20 minutes in. So I think I'm going to pause now. And I'm going to look at some of these videos. I guess I can just look at these videos while I'm still recording. Because I don't know what like a good project would even be. Because I got to ask ChatGPT. Wait, Sora? I didn't think this thing was out yet. Is this the video generator? Whoa. Four DP. Wonder how long this takes for generation. Oh wow. It's actually going pretty fast. I'm assuming there's no audio with these videos. That'd be kind of crazy. Wow, that's pretty shitty. This one's not horrible, I guess, but why does it look like a fucking 1940s sci-fi? So interesting. I wonder why it does humans so well. I guess that's you have a lot of human pictures, so I guess that's not that surprising. Interesting. Maybe I'll play with it around with this later. Kind of cool. Anyways, I wanted to work on a project in C that relates to a class I am taking next semester, which is computer architecture. Any ideas on a good software project to prep for this? Wow. Assembler for a custom instruction set is kind of crazy. I've already done this. This idea of a of building a custom instruction set and then making an assembler for that to go from assembly to machine code is kind of, it's cool. It's a lot though. That seems like a lot, but maybe. Okay, I'm gonna pause and I'll be back in a few hours. So, see you in just a second. Okay, I'm back. I kind of realized that I forgot to look at the API key that wasn't working yesterday. So I guess I don't know if I want to end right now. I'm not sure if I want to end this recording right now and then just work on that right tonight, and then tomorrow we can start it up, or 'cause I am really tired. I think I fixed my sleep schedule. Um I went to bed at like 4 a.m. and I think I woke up at like 9:30. So hopefully I can go to bed at like 11 or 12 tonight. Um, but remember yesterday the problem with the application was the API just like wasn't working for some reason. Um, and I think it's because I was in like a JavaScript file, so I'll make like a back end that I call to on the front end to do the request, and then we'll just see how it goes from there. Um, so either I'll be back in 1 second and we will continue working on the app, or I'm gonna come back and say bye. So you'll see in 3, 2, 1. It's working. Okay. So I had to make a I ChatGPT'd it, which we're gonna have to look over because there's no way I'm just letting this slide. Um, so I'll show you. Well, actually, you can see it generated and it posted this in here, which is amazing. This I'm gonna eventually want to put into a code block, but it produced the output and it displayed it, so that's amazing. So if we go here, this is what I had to put in here, which is not pretty, right? So what this is doing, obviously we can see we changed send request to, we're still getting the value of the input content at its current state when we do send request. The response area, we get that. If there's nothing in our input, then we say put something in the input, and then we update the area with processing as we're doing the try to localhost 8000, which is the HTTP server that we've made, and then API generate response. And so this is a type post with this, and we pass through our content. If the response is not okay, and then there's an error with the server. Otherwise, data is going to be what we get back from the HTTP server, and then we're going to say response area.value, update that to the response that was, so data.generate generated response. What is generated response? I would assume it's just response area.value equals data. Okay, anyways. It's, I know what it probably is. And so then if there's an error, then we send an error. So that's pretty simple. This, I have no idea. This was literally, so this is obviously we're importing OS so I can get my API key, importing JSON, importing HTTP server, and importing OpenAI. We make the instance of OpenAI and get the API key. So then we have a class request handler, which has the base HTTP request handler. We have a function which handles cores, which is like cross something something something. I forget what core stands for. But anyways, allow all origins, allow these methods, which is just a post method, and then allow content type and headers. Def do post, so that's this. So we're saying API generate response, which is where we reference here. Content length, okay. Post data equals self.r file read const length. Okay, data equals json.load post data. User content equals data.get user content. Yeah. If not user content, send a 400 error. Okay. So our try is going to be what we had before, which is just calling the API with this and then the user content. Where's user content coming in from? User content equals data.get. Okay, nice. With our temperature and our max tokens. Response content. Oh, is this what? Nope, still not that. Response content is the first completion of this. So if it's good, send a 200. Allow origins, blah, blah, blah. Generated response. Response content. So I'm guessing this generated response is where this is coming from. And then the running, this is just running on port 8000, running this actual server. So this HTTP server class, server address server. I mean, like I get what it's doing on like an a broad like kind of thing. Yeah, HTTP server listens for requests. Yep. Client front end sends a request. The server receives it, processes it. Yep. Provides classes for creating an HTTP server. Okay, I understand that. Okay. Class request. This class handles incoming HTTP request. That's how the server should respond. So, do options. Handles pre-flight options requests sent by browsers for cores. Okay. Adds headers to allow requests from other origins. Ends response with that. Okay. Handle actual requests. So when we do a post to the server, for example, if front end says draw binary tree, the server extracts draw binary tree. So all of this is saying content length is int self headers content length. The post data is equal to read file.read the content length, and data equals json.load the post data. Okay. Call up an API, yeah, that. Response content is equal to this, yeah. Sends it 200. Does another cores allow all origin, and then writes the response as JSON back to the client. Yeah, I mean, like I understand it at like a very abstracted level. I mean, there's so much here that is just kind of weird. So there was something else I really wanted to do, which was well, actually a few things. One was every time I get a response, I'm getting these as like a code block. I kind of want to make that, like the font of that, like a lot bigger. So like actually here, what do you think this should be, like 500 characters? Do I have to restart my, I don't think so. See, this is weird, but it's fine. Well, actually, weird. Anyways, I mean, so we have node 1, node 2, node 3, node 4. Call stack, copy. Do I really just need to like... Oh, shit. Oh, no, we're good. Before I actually run this, my app.py, rewrite that content for system to really make sure the visual is made large in between the I have a few things I also... I mean, I kind of like this kind of sleek already, not much to it design. Obviously, there's still so much I want to add to it, but we'll see, we'll see. I think I might do like a, you can change the font. An AI designed to produce large, highly detailed visuals followed by a concise essay. Okay, the only thing I want to add to this is I was thinking about this the other day, and it was like, right? And then I wanted to do cd server python app.py. I also want to get this that we're sending. See, so weird, right? Yeah, let's try this one. See what it does. I wonder actually also how much open if like how much is this costing right now? Again, I hate using this much ChatGPT, but like, bro, it's so easy to just like, I don't know. I mean, this is more for generation. I don't know. I don't know. Maybe I'm coping. Where should I add this, you think? I'd assume I could add it like right here. Okay. By the way, I don't need all of this. Why is there a double thing? Oh, you finally worked. I am so tired. Oh my god. Whew. That's so much cleaner. That is so much cleaner. Go from the try to the response. Still need to remove this though. Yeah, unexpected indent. Oh yeah, what the fuck? That how that works? That is how that works. Beautiful. Ah. So weird. So weird that it still does it. Oh. try again. Uh, don't wait. Can I actually? I don't know how that's processed on whatever the fuck. So weird. Interesting. Okay. What is actually? Sorry, I need to go back out. I hate reading it like this. What if I? Okay, so this is what I kind of want to try next. Is like, um, having this right, but then also in the prompt. But then like have a request for the request, right? So what would we do for that? So right now we have API, which is generate response, in which we attach this and we get the user content. But what if, right now what we're doing is we're saying, okay, we're going to pass through the system content and the user content. But what about before passing through user content and making the API call? We pass through user content and then instead of, oh, no. This is fine. Except I want to first do take user content, right? In my try block, I want to first call OpenAPI for formatting content. I need to use the bathroom real quick, actually. Get back. I'm back. Yeah, so I would say honestly we could do a request to like 4.0 mini, right? And we pass through So here we have system content, but honestly, we could probably just do user content. Oh shit. It may actually be a lot better to do format content equals this, and I just say using the prompt below, format it so it can best be received by a 4.0 API call to achieve the following. So this is going to be the format content. Message content. Message content is going to go through in place for user content here. Not what I was expecting. Okay, I'll just fucking manually do it. Okay. Whoa, didn't want to do that. I keep... Ugh. Let's see. Whoa. Wait. That is so weird. That is so weird. It just made a tree. It just made a tree with a trunk. I wonder how bad being this zoomed out is for the viewers' enjoyment. Let's see. Failed. There we go. Only took a couple tries. So weird. It keeps doing the same thing over and over and over again. I guess this is as good as it's gonna get. Yeah. It's as good as it'll get, I guess. You can put a code block. I wonder if it is just an HTML pre and code. Oh, wow. So I'm guessing it'll update the value. A little regex to find everything between this. Wow. That's sick. What am I doing? I have a nice, neat little new trick these days. Not exactly what I wanted. Well, that's not ideal, is it? That's not ideal. So how would you even change it? I mean, like right here, right? I don't believe that this is gonna fix it, but sure. Why not try? Change the texture in HTML response to a div. A div will allow proper rendering of HTML. Sir, yes, sir. God, I hate when it like. Let's. Background color. Yeah, I don't care about any of that. Alright, let's see. That did do it in the P tag. Much better. I mean, what happens if I do this? Uh, well, I want the background to be like try this. Where's all this up here? I don't really like this border. And honestly, 1 4 1 4. How does that look? It's not bad. I don't like this padding though. Like padding top should be like 0. Padding bottom. I guess this should be like 0 pixels, right? That white space shit can go. Oh, not all of that. Can you actually like expand this though? Kind of. Oop. Make a Ooh, that is kind of just cleaner actually. If I just made the whole right side that color. Actually, I'm gonna do that. Yeah, whatever. But this way, I can actually remove that. There we go. And then the button. See, like the button's like fine. Visualize this. Only other thing maybe is like would be on styling, making it a little less white. So like that or something. It's fine. Eventually I have to add a top bar, or I should. Actually, it would be kind of cool to do like a right side, like the height, like 95 with like a border radius, like 8 pixels. But actually, I kind of like this. It would be what? It'd be a padding of like 10 pixels. Actually, maybe this isn't what I want. I don't think it'd be a margin bottom, right? What the fuck? Is that because of the margin bottom? I guess it would be nice. Just kind of weird, right? There's a little scrolling distance here. Oh well. This doesn't look right. Function call start. Like, what is this? Wasn't there some shit where it was like where I could go like, yeah, that is. Wow. That's sick. Honestly, just use 4.0 again. I'm rich like that. See, this is what I'm assuming is gonna have to like happen. There's two things that I think I'm gonna have to happen. I think either we're gonna have to fine tune this model. Start base case. If yes, no, recursive call to function. Better. If we've met the case we want, return result, perform operations, call a function again, recursive function repeats. Okay, this is a lot better, right? It's still not amazing, but it's a lot better. Okay. Well, I think I'm gonna call it there for today. And just think of like something we can do here, because this needs some work, right? I mean the actual UI doesn't need to go. I would say, what do I need more for like the actual app? If the actual app, I'm gonna need a landing page. I'm going to need here. Let's type these out and then I'll wrap this video up. LeetCode's first one took a while. Learned some cool bounds, checking, logic. Second one was quick. Solution seemed easy. Alright, so we got the app working, but there are issues with the quality of generation and more just like as in the ASCII visuals are not up to par. Need to work on the following in coming days. One is going to be fine-tuning the model or providing examples / saving good examples. Either we're gonna have to do something where like see, this is just what fine-tuning is though. Fine-tuning is getting the model and its base weights, and then like actually, sorry about that, father came in. It's taking the model and the fine-tuning parameters and kind of just making it so like it'll keep giving the outputs that I like by just mathematical weights between neurons or nodes, I should say. So fine-tuning or that, and then making the following app components. So I mean, other than that logic, which is going to take a while, we need to make a landing page, B, a login and registration comes with auth. Also want to set up Google auth. C, user chat history, also maybe context. D, user profile and settings. And finally, E, on-screen tools, drawing, reprompting, copying. Okay, so these are all the things that still need to be done with the app. I'm sure there's other things too, but we'll figure those out. So tomorrow I want to focus on fine-tuning the model. I don't know if you can fine-tune 4.0. I don't know if I'm going to have to actually end up getting a smaller open weight model like Gemma or something like that. So we'll see. I'll test it out tomorrow. Otherwise, that is all I have for today, and I will see you tomorrow. Bye.